Talk about momentum transport or momentum operations, whatever you want to call it. Maybe even applied fluid dynamics, you might find that, or pumping and compressing, I don't know, or metering. There are plenty of ways you can understand momentum. And what we're interested here is essentially movement of fluids and maybe, of course, pressurizing, decreasing pressure, pumps, centrifugation, what else, compressors, and so on. So you can see there are several large unit operations, but eventually what you want to do is move fluids through all the unit operations. So this way we will need piping. So even though piping sounds something trivial, and when we do the block diagrams it doesn't is not of interest for us, in real life actually piping is very interesting, but because first, as stated before, they are required to transport fluids or maybe even solids, and you gotta be sure that there is no leaking. Maybe sometimes this requires a same temperature value, so you will need to add some isothermal fluid, or maybe they gotta be adiabatic, so you gotta find insulating material. If they are very high in temperature, you don't want to lose that heat, and if they are too cool, for example, they are chillers, you don't want to lose that as well. Also, we're going to analyze on pumps, plenty of pumps, how they work, the sizes, impeller size, efficiencies, pump curve, head of the system, etc. Then we analyze the compressor, which is nothing more than for compressible fluids, essentially gases. The only difference, well, I'm oversimplifying here, but one of the main differences is pumps are for liquids, compressors are for gases. And of course you're going to see cavitation and what happens when there is condensation in the compressor and so on, but that's for later. Now we'll also consider fittings. This is not so nice, but you're going to consider valves, check valves, butterfly, gate valves. Why do we need them? How they are used to control velocity, pressure, to decrease flow rate, and so on. We talk about also on the pressure drops, change in velocities, volumetric flow rates. So yes, this is very interesting, and this is of course seen in mechanical engineering. So this is interesting because if we have relevant chemicals, here's where the chemical engineer will outperform the mechanical engineer, because sometimes those materials, if you increase pressure, they will flash, or well, actually they will condense. If you decrease them in pressure, they will flash, they will make the pump to cavitate, and so on. So this is very important to consider.